go. So I haven't really done any work since was it Thursday night? What day do we have? Thursday. So I guess it was Thursday night where I started this work. So I haven't really done anything past that. The thing I did immediately after turning out the stream is I did a little bit of cleanup and refactoring. So we now have all this stuff encapsulated in this thing called profile session. Um, and so that's how you configure things and using the struct to pass stuff around. There's actually one additional split in those related to this I'm planning on doing very soon. Other than that, I think I fixed one bug where I wasn't doing, when I was doing an image unload, I wasn't actually doing this typical thing where you copy in the last element to the element being deleted, and I think that's it. So I guess to get started, we should just make sure the fucking thing is still working. Seems to be. Oh yeah, the other thing I did is I turned on the sample events. I was just, for a while I was just printing the call stack since that's where most of the action was. Alright, yeah, I remember one thing I left off that I never got to the bottom of is why the timestamps for the stack events and the sample events are not consistent. I think it's because I'm not using the headers timestamp. So if you read the docs for the, do I have that open, Stackwalk? If you read the docs for this event timestamp, it says this timestamp is the original event stamp from event header. Use this timestamp to match the stack to an event. In other words, this is supposed to be the matching key for the whatever other event this call stack is an annotation for. Now the thing that doesn't make sense about that is the if you look at just the range of these things, they're like way off. Like this thing is, let's say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So you can see this is like 5 or 6 digits more. I have one suspicion about what that might be, which is that maybe this is maybe these stack things are relative to the beginning of the session, like the first timestamp of the session, whereas these are like, you know, absolute relative to some baseline. So maybe I should test that hypothesis. Maybe for now we'll just have. I think these timestamps are. They're large integer, so maybe if I do I should also pull this out because we're going to be using it, and I think we're already using it. So I wonder if we do this. Oh wait, that was after I changed it. I guess the original was so first timestamp plus. No, sorry, that was for the stack. So that is right. The stack one, right? Maybe try that. people are showing up. All right. Oh. It should be pretty easy to sanity check this guess I had because I would expect. Okay, so that's actually. So now that we did this offset, so I think that was actually right, or at least right enough. I mean, at least now there's. I guess that's kind of cheating because if I take a really large number and add it to a smaller number, of course the result is going to be close to the large number. So I can't really use this as a sanity check, can I? Because they're too far off. Like the way I was going to say we can sanity check it is, I would expect the stack events to follow almost immediately subsequent to the original events, or right before, or right after, or something like that. So I would kind of expect these to match up. So maybe that's not right. And you can also see here, so this is a CCC stack walk event, and it has this thread ID, and here's the thread ID here. So you'd kind of expect this and this to be the same. And I mean, it's not even close. So, okay, so that was a wrong guess. Hmm. The other thing I was going to say is that the way I believe the way these stack walk events work is that, well, so first up, what's the first stack event? Okay. All right, so there's a lot of, at the beginning of the session, there's a lot of sample events without any stacks. And then we start getting stack events. By the way, when I say a lot of samples, I guess I should qualify. I believe the default sampling rate is 1,000 hertz, right? So this is actually not a lot. This is a fraction of a second's worth of sample events. And we start getting these, and we get 3. We get 3 with the same timestamp. We get 3 with the same timestamp. I have 4 processors in this machine. 3 and 2, so we don't always get all of them. I mean, I was going to say that maybe maybe you don't get one if the process is if that processor is idle, but we're getting idle events here, so that can't be it. I wonder. I mean, just offhand, does anyone here know how? What is it like? Was it APIC timer? How do APIC timers with multiple cores? Like so sorry, I guess I'm not articulating my thinking, but like basically I'm wondering if you set a timer interrupt on a modern processor, how does it work, right? When you have multiple cores. I know how it works back in the day when you had one core, but I wonder with a modern processor, if you set a timer interrupt, is it somewhat asynchronous between the different cores? Like you basically configure it for each core, and so they might be slightly, in other words, I can imagine one way it would work is that you set it once for the whole system, and then when it occurs, all the other threads are halted. Now, the thing that's problematic about that is presumably one of the cores is the one that would be initially halted, and then they would have to stop the other ones. So maybe the way you actually do it is you program it separately for each core, in which case, it's possible if a core is entirely idle, you never get the timer interrupts for that one. I don't know. I guess there's also a question of whether this stuff uses the APIC or the PIT. Okay, this doesn't seem very useful. All right. Hey there. Okay. Maybe I'll come back to that later. The thing I actually wanted to dive into now was symbolization. So let me just recap for people who weren't here on Thursday. Um, yeah, I'm writing in C++. For the people that weren't here on Thursday, I'm basically trying to write a simple, very sleepy style sampling profiler. My main pain point with Very Sleepy is that it's extremely high overhead because of the way it samples using suspend thread, get thread context, resume thread. And so I wanted to basically do something with that level of sort of simplicity, but using ETW, which is Windows' built-in event logging system. It's one monitor. I only have one monitor at home. But anyway, so on Thursday, I think we got pretty far. We captured traces from ETW with sample profile data, uh, image load, thread create, stop, process create, stop data, so that we can actually kind of make sense of the process IDs and the thread IDs that are in profile events. We have call stacks, which is this thing here, enables call stacks. Um, we have uh, we have basically parsing of the ETW events. So um, what you're seeing in this file is basically me processing a ETL file that I already captured earlier. And so the two main pieces of data you care about here, there are sample events, which represent, like basically a timer interrupt, triggering and sampling the current instruction pointer and process and thread ID. And there are stack events that have stack walks of wherever a given thread was when it was interrupted by the timer. And the thing we spent a bunch of time on last was figuring out. Well, there was this particular stupid underdocumented area with SIDs, which are these variable length um, security identifiers that were embedded in the process events, and finally figured out how to actually like the layout, because the this user token, these two pointers that I called user token, are not documented. It just suggested that there'd be a sit there directly, and so if you try to read from this, you get all garbled data, and so that took forever to debug. It took like an hour for me to figure that shit out. But anyway, now that we have that, we can read to the image file name. We can do all that good stuff. We also have these image load events we get. Basically, an image is something like a DLL or a sys driver or a XC executable. And once we know what images are loaded into a process, we know what virtual memory range they span. So they go from base up to base plus size. What that means then is if we get a instruction pointer from either from a call stack or from a sample, a profile sample, we can call this function get image for instruction pointer, which basically just walks through the array um, of images that are loaded for that process and finds the range this thing falls in and then returns that image. So given that, we can now symbolize stacks, or not symbolize. We can at least we can at least figure out where a given instruction was, like what image it's in. So you can see here, this is a sample from the profiler itself. Funny enough, you can see call stack starts in NTDLL, goes into kernel 32 DLL, then has a bunch of functions here, and then goes into I guess this is message box, right? Because there's a message box call in my code. And so you can see all that, and it's classified it by DLL. Now, the reason we're classifying by image is not just because it looks nice or whatever. It's because the next step from here is actually turning these instruction pointers into symbols. And in our case, we care about function symbols, because once we can turn these into function symbols, we can then start bucketing all these different traces by functions. And we can say, for example, here's the hardest, here's the function that spends the most time. Like, and this function spends 10% of its time on a core, or stuff like that. We can't do that directly on the instruction pointers because we don't know how things slice up into functions. So the first steps toward that was what we did on Thursday, which is figuring out the images that are loaded. Now that we know what images are loaded, we can actually go use the debug help DLL library that's built into Windows to start parsing any PDB data that may be available, from which we can transform these instruction pointers into function symbols. And from function symbols, we're very close to being able to do some actual useful analysis on this profile data. So anyway, that's kind of where we are, and I guess where we're going. Yeah, this is not really going to be a tutorial stream. Sorry, this is pretty advanced. All right. Okay, so I think we should probably start figuring stuff out for debug help. So in case, for those of you who maybe know a little bit about debug help, there's two built-in libraries in Windows. One of them is more, I guess, built-in than the other. I think the most basic one is debug help. I believe this one is basically always ships with Windows. Then there's one called DIA, which is a COM library, and I believe DIA is just built on top of debug help. And so debug help is sort of an old school C API in the good old Win32 vein. And DIA is, well, I guess you can call it more modern, but it's certainly different. It's a COM API. Back when Microsoft, well, I guess they were still on the COM wagon, but back when they were really on the COM wagon and everything had to be commed up. So I actually don't think there's anything you can do with DIA that you can't do with debug help. It's possible DIA has some convenience functions that would make things easier, but I like this basic C style more, so I'm going to use debug help. It's also the only one I've ever actually used before, so that helps as well. So, okay, I think actually before we dive into that, I want to start laying some track for just keeping things like a little more organized as we move into that work. Right now, all the processing we're doing is in line with the callbacks after we call process trace. So when you call process trace on an open trace, it basically calls your callback in sequence for every event in the trace. And so we're already, all the logging is happening in line here. The way I was thinking we would organize the data for our subsequent work is that this pass that does this sort of process trace and callback crap, this would basically transform the raw ETW data into our own data structures so that we have an easier time making sense of it. We already started doing that a little bit with these image info and process info data structures. So you'll note that these data structures actually represent not events, but sort of persistent objects that we want to reference. And in our case, we were just referencing them because we wanted to figure out like what images are loaded, and so we can resolve instruction pointers. But you can imagine like you could very easily do like something like this, right? You could very easily add interval load unload tags to these if you wanted to. In which case you basically have the same data that's in the event data, but the difference is that this is organized by object rather than by sort of edge trigger event. So I think this is going to be much more useful for the work to come. So I think before we dive into the debug help crap, I think I'm going to start kind of figuring out how to lay out and structure that data. So right now we have, what is that thing called? It's called a profile session. I think we're going to rename this to profile capture. I guess we should rename this to delete all capture. Make sure that still compiles. So my idea is we now separate a little more tightly the capture phase from the analysis phase. And so right now we're kind of doing a little bit of both at the same time. I do have these two functions that actually, so maybe we should call this start profile capture. I guess I should rename this as well. Start profile capture and stop profile capture. Yeah, we have to go and rename these things as well. And then rather than processing the profile, well, what does that even mean in our new scheme? I think what I'm going to have is I'm going to have a notion of a profile analysis. And so a profile analysis is basically our own representation of the data that is contained in the capture, which is just, the capture is just basically a raw ETW event stream. So we're going to have something like this, where we take the capture and transform it into an analysis. And I think I want to rename these image info should be profile image. Process info should be profile process. I think I also want to rename this to just file name. Okay, so we haven't defined profile analysis yet. I think I'm going to move this earlier in the file because maybe I'll keep this at the end. All right. Yeah, okay. So I think a profile analysis is going to contain, what should it contain? It'll contain a bunch of images, a bunch of processes, a bunch of samples, and let's just say that's it for a start. A profile sample should have a timestamp, and it should have a process, and it should have a thread. We also need threads, actually, so that maybe I should go and do, I don't think I have thread create and destroy stuff hooked up right now. I'm capturing the events, but I'm not actually processing them. So I should do that, but maybe we'll just do that for now. Because, yeah, so if you look at the raw ETW data, they have process IDs and thread IDs, but they don't, but what we want is actually something that's a little more, that lets us directly go and get the process data. The problem with process IDs and thread IDs is that we definitely should have just a process ID in here as well, so we know what Windows thinks this thing is. The problem with using process IDs and thread IDs is that they're not permanent identifiers throughout the trace. Like a process ID and a thread ID can be reused, so there's no way you can do a unique lookup unless you know where in the stream you are, and then that lookup has to be sort of sequentially from the beginning of the stream to where you are looking it up. So that's awkward. So we're going to try to basically remove all that ambiguity by constructing essentially the total picture of what the stream represents, and then kind of link everything up, so we don't have to do that every time we want to figure out what process is associated with a sample. Does that make sense? Um, all right. Oh, and I think we need a profile stack. I think a stack is just a sample has a call stack. We need a call stack length. And we'll just call it stack and then stack length. All right, so images, processes, threads. Processes also just start adding this data. Start time, stop time. Load time, unload time. Maybe I should change this, but for now I'm just going to leave it in line as a big array. Threads are going to have create start times and stop times as well. They're going to have thread ID. Okay. Let's see here. Okay, I think what we want to do now is turn this into something that doesn't just print but actually fills in the analysis. So this will be initial app profile analysis. And so it'll grab stuff from this, and I believe this thing needs, is it user data or callback context or whatever it's called? There's definitely a way to pass in a user data. Maybe this one. I guess we have to go look at that. I see. So context is the one. So context is going to be our profile analysis. And so just going to delete this for now. I don't think we need this. Okay, so let's handle these other ones we already do something interesting with, like when we create events. So boom, 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 boom. I'm going to start doing this malloc stuff. I have this, I would like to do something. Actually, the thing I want to do, it's going to be more convenient and it's also going to be much faster, is I'm just going to use a big linear allocator for all the process analysis stuff. So basically I'm going to allocate like a big reserved range to contain all the profile analysis data, and or maybe several. one for each of the major arrays, like the process array and whatnot. And then I'm just going to have a linear allocator. And that way I also don't have to do anything really to free it. I can just do a virtual free to free the whole thing. It also means that I have this big contiguous thing I can write out to disk very easily. Because I have this notion that eventually I want to be able to write out a profile analysis to disk, so that if you want to keep multiple traces over time or multiple analyses over time and diff them or something, you can do that. So I'm not over engineering that. I'm just keeping in mind a little bit that if I keep things nice and linear for the allocation, then that stuff will be much easier as well. So I need to have, so what were the things here? I have images, so maybe it's like create profile process. So I guess we need we need some counts for these regardless. So let's just add these. And then when we do this, well, assuming the array is big enough, which for now we're just going to assume, it's just a question of really returning, which I guess maybe we're going to change later. But for now, we're just going to create functions, because I think we're going to have to eventually. Well, it would also be nice to just have an assert actually, once we get there. But okay, analysis plus. We're going to have one of these for images as well. All right. Actually, let me call this add, which is really more representative of what it does. Add profile sample. Images to din. And okay, so images, processes. All right. I guess one thing we have to do differently is we shouldn't keep these in line. These should basically be pointers. Even if we keep this max images static array crap, which probably we should replace, but at the very least we should just store pointers. And maybe we'll replace those pointers by indices later, so we can easily keep it position independent for serialization. But for now, let's just do that. And all right, so we're doing this, and then for processes. So I think the step here is when we get a start event, add profile process to the profile analysis. And having added it, we then have to fill it in. So I think we already have a file name. So that's going to be this thing. Actually, it shouldn't be because this is... Yeah, well, that's fine for now, but we have to stir dupe it. Stir dupe, I want to do my own heap allocation. No, that's fine. We're just going to assume these are infinite arrays for now. We can always check it later, but I am going to do some sort of big array allocation, so it shouldn't be too infrequent. All right, new data end is that, and then we have to do an alignment. So actually, I can't do that before I figured out the alignment. Let's see if I remember how to do that. Let's do 8-byte alignment. Data plus, well, we have to... let's see. We do this. If this is 0, we're good. If it's greater than 0, what's the easy way to do that? Oh yeah. No, that's data end, not data itself. Let's see, and then we want to do actually, let's do like this. So this is the data end. And then we assign this to the address. And then this is that. And we return pointer. Is that not something called that? Oh, not 64. Analysis data end. Let's just make this a char pointer, and then we'll cast it on return. All right. So converting. Right. So. think I should also maybe clean up some of these names. File name is okay. I don't think this should be called base. This should just be called, or image base, just call it size. And this will be default base. That's still good. Process ID, I think it's good, even though it's redundant with the name of the class, or the struct rather. Image count, I think I'm going to use plural. Images count, I'm going to put it after start time, stop time, timestamp, stack length, process, okay. This looks good. I should probably just be consistent and use sizes rather than endpointers. Nah, I think this is more convenient since we're using more pointer arithmetic on those. Alright. Alright, so image base should just be base. Image size should just be size. Oh, I guess except for those, where we're actually copying them from EZW. And I suppose that one. Okay. Okay, so where were we? Processes. So we do an add profile process, and then we... Is it still called process info? Okay, so we're gonna move that down here. Eventually we're going to have to replace these STL maps, but I think for now, so the nice thing about this capture versus analysis split is that even assuming that I keep using these maps for, and also they should be unordered maps. Even assuming I keep using them, they're segregated basically only to the stage where we transform the capture data to the analysis data, because they're used for basically correlating PIDs and TIDs with the actual objects. And so once we've constructed the profile analysis, they're no longer needed. Everything is already linked up. So, okay. Does this look right? I think there's maybe more to fill in. I'm just going to delete this because I don't think we're going to need it. File name, images count, process ID. Process ID we definitely need, so that's event record. Well, process ID. And start time would be the current event timestamp. End time is, I guess 0 is a good default value there. I think that's the order I had, maybe like this. Which one is large integer? Oh, I should do like this. All right. So now this is fairly clean. And then I used to do this, and I'm still gonna, but I think one difference is that rather than freeing these, I'm actually just going to set their end time. So the stop time is going to be whatever the event timestamp is. I still have to remove them from the map because this map represents the current mapping between process IDs and process objects at the time of the event. So we still need to maintain this map, but we shouldn't free the profile info the way we did before, and now we just set the end time when this thing was stopped. All right. Okay, this looks okay now. And then we have to do a similar treatment for this. So we add a new image. And now we actually, oh yeah, I guess this is off of the main analysis heap. So we still have to do the process images count increment. So having done this, no, I guess that's not enough. So now we have to say process images count equals profile image. Okay. Oh. The other one I didn't do correctly up here is I wanted, let's see, so that's file name length should be this. Then I do allocate profile data, profile analysis, and we want to allocate this +1. Actually, I'm going to just do the +1 up here. Otherwise, we're going to make mistakes. And then I will, I'll just copy the data like so. What did I do wrong here? Sterling is, okay, size T. It's a very long string. It can be 64-bit required, okay. Yeah, I mean, I should definitely make these size T's. Alright, what now? Cannot convert from, okay. That's fine. Alright, that was the next thing. That is fine. So, okay, now we're not using stirdupe. Start time, stop time, and process file name, and images count 0. Okay. So where were we? We added this to the analysis. We added an entry for that pointer to the owning process. Now we're filling in, what were the other file names? Oh, these are called profile image. So base, default base, file name has to be converted down there. Load time definitely should be the event timestamp. The unload time provisionally should be 0, which just represent an absent time. Then we do file name down here, and instead of doing a malloc, we're going to do my allocate profile data. guess we have to. I mean, I think that really matters, does it? Okay, we'll do it. I think that does it for this stuff. And now for unloads, we are going to I guess this is the question. Do we actually, since you can dynamically load and unload things during a process's lifetime, I think what we do is we actually don't do that. So we don't actually do this. If something is added and then removed, and then something else is added on top of its old base to size range, I think we just let them overlap and we disambiguate by the start and stop time. So all we have to do here actually is to, and we should call this profile process for consistency, we just set the stop time to the event timestamp. And I think that's it. Sorry, this would be the unload time, not the stop time. Yeah, don't need this anymore because we never actually, well, okay, let's just leave it like a comment. Okay, I think we're ready to run stuff soon. Although, let's do the samples while we're at it. Okay, when you get a sample, profile sample, we just call it time rather than timestamp. And stack length is 0. And actually, stack, I think I defined it as a void pointer. It should be a void pointer to a pointer. Oh, and the other one should be timestamp. Okay. So where were we? So this is 0. Is there anything else? Oh, right, process. I don't think we have, we need to hook up threads as well, but for now I'll set it as 0. So for process, this is where we need to, well, let's see, sample profile doesn't have process, does it? That's thread ID. But you can use the, well, let's put it up here actually, event process ID. stack walks, I think we are just going to skip them until we have to figure out the allocation strategy for these. Well, the allocation strategy is actually easy. I think we do the same thing we did for allocate profile data, which is we just do a variable length allocation. The question is, I'm still not sure about how to perfectly correlate samples to stacks, so that will require a little bit of investigation once we get there. So okay, I think this should, we'll see what bugs, if any, there are here. Should I call this create profile? No, initialize. There's no more process profile. All right, we haven't actually. So initialize profile analysis also needs to allocate these big arrays. And actually, I should put that in the profile analysis so we can also do bounce checking. And I think what we're going to do is we're going to assume that whoever calls this function has already filled in the those fields, and so we're just going to allocate based on those allocated capacities. Maybe that's a little user unfriendly. Nah. So profile analysis data is going to be, well, let's make some utility functions, since I don't like typing virtual analog with all those parameters 10 times. So virtual allocate. Let's see. First one is size, and then the next one is allocation type, which is like mem reserve, mem commit, and then there's page read write. Well, that was not really the first thing. Okay, let's just hardcode some numbers, actually. How many megabytes? Like 128 megabytes. Oh, and the other thing I want to do in this function, actually, let's make sure I don't want to handle partial. I want to have to deal with the failure at the call site. Data end is equal to profile analysis data. Okay. There's like processes. How many processes can we have? I don't know. What's a reasonable number? Let's say 1,000,000. How many samples? 1,000,000 is definitely not enough. Well, at 1,000, let's see, at 1,000 hertz, that's 1,000 seconds. Let's say 100 and... Well, the other one was bytes. And the sample has, what is it, like 2 pointers plus a timestamp, so that's 24 bytes. So 128 megs times 24. That's a lot. Maybe we'll just do like that. Oh, this is also samples. What was the last one? Okay, images. So we did processes and samples, and we have to do images. Well, we're going to have an image instance per process, pretty much. Let's see. If this is 1,000,000 processes, that should be... Well, what was our max images before? Yeah, that's a big multiple. Which is way too much in the worst case, but I guess they're shared. Actually, one small note. This is anal, but I don't like that, having these like that. What's a reasonable number? I mean, this is probably too large. Well, what's okay. Yeah, I don't know. I think this should be more than enough. Alright, let's try that. I think this is whatever the default color scheme is in 2015. I honestly don't really like it, but I also don't really care. Alright, I should go back and add asserts for those. So once we've added this, I should assert that pointer plus size is less than data max. And in this case, I should assert that hate comments, especially when they're self-explanatory. All right. So I think we should be able to run without crashing now because we have all these allocations. I think they should be ample size, and if they're not, we also have the asserts to catch it. Let's just do a quick read. Looks good, looks good, looks good. Oh, one thing I didn't do right is that I didn't multiply this by the size of the data structure. Okay, let's try to run it. Oh, that finished. What? It's a little too good to be true, isn't it? Does it actually execute? Alright. Well, actually, let's more breakpoints here just to make sure. Okay, so that seems to be executing. And given that this processes map includes pointers and stuff that are referenced during these various events and dereference rather, if things were completely off, I guess I would expect it a memory crash. Alright, so maybe that's not too bad. I think we're rid of all mallocs except for this one, which I don't care about. And also stir dupes. Yeah, fuck stir dupe. So let's just glance over these to make sure everything is still reasonable. I guess the thing we should do is we should re-enable the logging for stacks and make sure that using these refactored data structures, things are still printing what we expect. And it seems to work. I feel like I feel bad about doing these big commits. I should do the typical reserve and grow trick, but then I have to manage not just the commit max, but the reserve max. So probably I should do that with chars so I can do easy arithmetic. So maybe what I do is I allocate range. I provide a reserve size, and then an initial commit size. Actually, initial commit size is just going to be like a page or something small. So let's just do it like that. So we do that, and okay, the reserve end is the base plus the reserve size. Then we should do a virtual protect on the base of, oh, I guess I'll just, there's a way to get, I shouldn't have magic numbers. I should have, what is it, page size. There's a function to get that. Virtual memory page size. Is it like, I think it's called minimum, get minimum page size. Okay, we're just gonna hard code it. We're gonna kill this fucker. Okay, so we do that, and new protect. Wait, is the protect? I think that's not what I want. I think I want to use virtual alloc again, right? Cannot spend. Because memory protection is like read-write, not, yeah. So I think I have to do a virtual alloc. Yeah, so I want to do another virtual alloc on the base, and I do it like that. I don't remember what it does to an existing. Is see the return is it base as okay. So I want to I don't actually care about that because it's going to be the same thing I passed in, but I want to verify that it's exceeded. And then I can set the commit end to the range base plus the page size. Okay. That's easily dealt with. Okay, so allocate range, and then typically the thing you want to do here is you want to have something called commit range, and you all you do is you pass a pointer, and so first off, you should definitely verify the pointer is within the reservation range. So make sure it's within the reserve range, and if it is, and it's if it's before the commit end, then we don't need to grow it. So only if it's at that point do we need to actually guess we need to do it like that. And then this needs to be like that. Only if the base pointer plus size goes like this, then we have to take the existing commit end and let's see, commit end minus pointer, and then commit page read write. I'll just do it like that. Okay, let me just verify I didn't screw up the math. So I have to also update the commit end. I have to update it by, so it's going to page align, the commit end is going to be page aligned. So I have to commit growth. It's this thing. I'm going to page align this. And something like that. Ah, I see, okay. Maybe that's the one. I'm just going to stick with the hard-coded, which is probably fine. Alright, so, okay, so we would, let me just read this code to make sure I didn't fuck it up. We do the initial reserve, then we commit the initial page, we update the commit end accordingly, and we make this point to the reserve end. I think I should also page align this, just in case. Well, I don't think anyone can complain for reserving up to a page more than you asked for, so I think probably aligning it is fine. Reserve size plus page size minus 1. Okay, and then instead of doing the virtual allocs, I think we are going to processes. I think we're going to have some ranges, processes range. So we're not going to have capacities anymore. We're just going to have these ranges. Okay, so now when we do this, we can basically just grow this as we want, and then we have to do a commit range on the data range, and the commit range goes from, I guess, the existing data end to the new data end. So what is the complaint about? Cannot convert from, pointer is the aligned. Yeah, I guess I could do okay, so instead of doing this assert here, we just do a commit range, images range, and what we commit is profile image pointer, which has this size. Okay, so now we're just going to do a reserve range or allocate range. And because it's a reservation, it can be extremely large. We don't have to really pay for it until it gets used. And instead of doing this, we just do profile analysis, processes range, base. We do have to cast it. In theory, we would have to do an initial commit range, but as long as our data is less than a page, we should be fine on that end. And it, I mean, yeah, it should be fine. Actually, you know what? I'll do this. Initial commit size. All right, so this should be a lot easier because now we can just do it here. We don't have to be sloppy about whether the thing we're allocating is initially large enough or not. Okay, so does that look right? Does not have an over. Okay, yeah, it's not a pointer. Okay. Why did I do this? Because I'm... You know what? Well, maybe I'll keep the initial commit. No. I actually don't need it here. All these are created empty. Fuck that. For some reason I thought it was an allocated initial entry, but once these ranges grow from things being added, they will those actions will commit, so we don't have to do shit here. All right, so it goes like this. One more virtual allocate. Data range. So allocate a range. And how big? We can make these monstrous. Yeah, we don't need data max anymore, so we just do it like this. And then data range base. Okay, so let's see here. So we're trying to commit that pointer, which looks like, where did that come from? Looks pretty low in memory. Oh, I think I know one of the mistakes. I forgot to multiply by size of process after I reorganized all this shit. Okay, also at least maybe it's something else here. Okay, so base is here. The pointer, okay, so the pointer is equal. The reserve end is up here. So these are equal, so this passes. The question is whether this... Why is this size so big? Oh, I see. It's because I have this max images thing. So the profile processes are like fucking 16K. Let me just check something. How big are those ranges? Those are tiny. Why are those ranges so small? I thought I made some big ass commits. Or big ass reserves. Let me restart. Oops. Yeah, so we're trying to do a fucking monstrous reserve. Oh, I fucked up the commit math. Oh god, I know what it is. No, that's not what I want to do. Oh, okay. My fucking alignment math is brain dead. I don't know what I was doing here. I want to... I only want to mask the lower bits. So it's like this, right? I was using the inverted mask. So yeah, I think this was actually fine. I had a suspicion. Well, it doesn't make sense anyway. So let's see. So I think this is right. And then this was retaining only the lower bits when what I wanted to do was retain only the higher bits. Let's just make sure I didn't have any other... Okay, those were the two cases. Okay, that actually worked. That was just it. I'm just an idiot. Okay, just glance at this, make sure it makes sense. I don't know how much you guys use this trick I just used, but if you're on a modern 64-bit machine, this way I just allocated memory here where you make large reservations that encompasses a fairly extreme worst case, and then you do commits on demand. That's like a really great technique. It's hard to beat. And then you end up with nice virtually contiguous memory as well. So if you want to serialize stuff out to disk, so for example, right now, if you look at my profile analysis data structure, I have 1, 2, 3, 4 different ranges, and so you can think of these almost like sections in a, like in a PE or an ELF file. I could write these out each with a separate write back to back, because they're all contiguous virtually, so it's very easy to get them in and out of memory. The one thing that's a hitch right now is I use direct pointers rather than indices. If I used indices instead of pointers, then I wouldn't even have to relocate the pointers on load. But we're maybe going to do that later if we actually do serialization. Just one sec. Oh yeah, so I actually fucked this one up too. So what that means is I would be overwriting the same characters in place when I'm using this allocate like character data. So, all right. Okay, let's see. I think now that we've constructed this data, so I'm going to turn off these as well for a sec. I just had them turned on to make sure that the image and profile data was being built, were still being processed correctly. But I think now that initialized profile analysis supposedly actually populates all the data we care about, we should do like a dump or something. Like we should just output profile analysis. We should just do a traversal of all the data. So processes count. I guess that's a good place to start. What do we want to output? Start time, which I think 64-bit stop time also. Let's start with those. Actually, let's call it dump profile analysis. Output. Oh, interesting. Is that because of the... Well, let's see. That's a fucking huge request. Oh. Okay. That looks reasonable for the processes. None of these have stop times. I thought I filled those in. Okay. Now those have stop times. I guess I should do the same thing for these. Yeah, I think the thing I just did is what caused that issue. Okay, I think that's the issue. I can only, in a DC end, I can set I can't actually erase it, I can only set it. I think that's why I didn't have it originally, so I'll just keep it like that. I'm just going to copy and paste it for now, but I should pull this stuff out into a function so there's no duplication. So in this case, well actually I can unify those because I already don't delete stuff from the images arrays. Alright, so I think we should work now. Okay, so we get the unloads and we don't get that assert. You know what, I'm just going to unify them. And then do okay. So let's do the same for, actually let's do it this way. I'm gonna move this earlier just so you have something to visually anchor on when you're reading these things. Um, okay, that looks reasonable. Um, okay. I'm happy we did this, even though technically I mean, sometimes we just move data in one form into another. I think it means that all the stuff we have to do now will now become, you know, we'll be less in the hole on sort of ad hoc decision stuff I made just for the expedience of getting the ETW crap working. So, all right. I think this is pretty much it. Still have to figure out what to do with the stack data, but for now I'm just going to have null stacks and just resolve the samples themselves, because I think the next step is actually symbolization. Oh, actually, let me print the samples. I do, because those are obviously the main course of this whole thing we're doing. This is also a... Oh, and actually, so something I want to do here, I think, is process... Well, processes don't really have... Okay, so let me do this. I should... Since one of the things we did here with this refactoring is that we can now do something like this. Like, we actually don't just have process IDs, we have process object pointers. So let me just see if that actually works before we print the samples. Oh, I guess we don't reverse link images to pointers, but we totally could do that. I don't. Maybe that's not too useful. Yeah, that's not too useful. So we'll get it from samples anyway, because a sample will be. We have a time. Let's not print the stack because it's just going to be null. We have a process, and that's it, I think. So profile sample. We have a time. And we have a process, and the process has a file name, so we should just be able to print that without... So previously, in order to do this, let's see here. Oh yeah, I wanted to delete that. Previously, in order to match up a sample with the process's file name, you had to go through like several levels of indirection through an STD map and crap like that. Now it's just linked up, so it should be straightforward. He says as he crashes. What was the error? Oh, there's a null pointer, or an almost null pointer. Oh, the process is 0. I think we actually didn't fill in the process. So we have to go to... Oh, I see. I guess, yeah, I actually knew that from the initial work. we're going to leave it. There are some sample events that for some reason occur before we've received all of the process start events, and so they are not linked up to anything, and we can't really do anything with them. I think what we should actually do is just discard them, because we can't do anything. We can't account for where they're. It's literally just a pointer at that. Well, I guess it's a process ID, but we don't really have a good way of linking them up. So maybe what we do is okay. Okay, it says there's no samples. Did we not print anything? Oh, maybe it's saying that all of them don't have a parent. That's interesting. Let's set a breakpoint here and see if that hits. Oh, so that doesn't hit. So this is always coming back empty. Maybe we can't match them up based on process ID. Maybe we have to use thread IDs. Let's see here. Yeah, the event process ID is just complete garbage. What the fuck is this? I guess it's not filled in for some things. Is it really just complete garbage? Yeah, it is. I guess because they want the sample profiles, the profile samples to be really small. Okay, well, this forces us to also start doing the same management we've been doing for processes to we have to do the same stuff we've been doing for processes for threads, and then once we have that, we can because if you look at this data structure here, it actually has a thread ID in line. So maybe that should have tipped me off that the header, thread ID, and process ID are actually not filled in. Okay, that's fine. We have to do it anyway at some point, so let's just do it. I already started filling this shit in. This one will definitely need a reverse pointer to the process, because that's how we will be able to go from a sample to a thread to a process. Alright. Well, that's a good opportunity to do that. So we need something similar for threads. I'm actually going to start replacing these by size t's. I don't know why. I mean, yeah, I should just use size t's. I have this thing, the stupid part of my brain, which is like, we're never going to have more than 4 billion processes, so I'm just going to be super economical and save a whole 4 bytes. Not even 4 bytes inside a struct that's replicated a million times, but 4 bytes for the header. So that's just me being stupid. Threads count. Let's see if that works. Threads range. Okay, so processes range. So there's I need a thread range, threads range. So what were you saying about the reserve commit thing? You learned it on Sean's stream, Sean McGrath, not Sean Barrett. The way he was using it was to let access violations happen and use SEH to recover and commit. Yeah, that's another thing you can do. I think that's probably, I mean, yeah, like that's actually more efficient. I guess. I think the advantage of that approach, Well, you avoid the if check. Every time I do a commit range, I I mean most of the time it's just this is like a really well predicted branch, so this is honestly not that expensive. I would say where this would maybe become expensive and would be worth doing the sort of lazy exception SEH approach is if you're doing increments of a single byte, right? Like so you're doing effectively commit range with a size of 1, then the overhead of this, if you're doing like a large number of bytes, could be unacceptable. Um, but if you're doing this for like larger granularity chunks, like my profile data structure, like I'm doing it at the either at the string level for a whole string file name or for a whole profile process struct or something like that. In that case, this is honestly fine. But yeah, the SH thing is a nice way of doing it lazily. The operating system actually does something like what Sean is doing, also using this thing called guard pages, where when you create a thread stack, including your main thread, it reserves. So for example, the main thread on Windows by default is reserved to be 1 meg. So it has virtual address space of one megabyte in length reserved. But initially, I think it only commits maybe one page, maybe a couple, and then at the frontier of the committed range, it sets the special guard page flag on that page. And that's basically a signal to the OS. Then when it faults trying to read or write that page, it will basically do what John is doing, but it will do it without round tripping and extra time through the user space. Because when you use SEH for this kind of thing, there's an extra context switch to because it has to go to the user space to do the SEH, and then you have to do the resume, which I guess in this case would go back to the OS, which then goes maybe back to the process. Maybe it actually doesn't have an extra context switch. But in any case, the OS does something similar using guard pages. So he's basically emulating guard pages. All right. Let's see here. I lost my train of thought. Okay, threads range. I think threads range, but we have to still allocate memory for the range and initialize it. So we're going to do that here. Threads range. I mean, you can make these, like I said, really, you can easily make them gigabytes. It's no problem. These are actually not that big. So this is a megabyte, this is a gigabyte. I'm just going to do this, oops. I mean, this is really profligate, but that's one of the nice things about the 64-bit address space. So that was, by the way, the other thing. It wasn't just the use of reserving and committing. It's also the idea that you can do a really worst case estimate of your reserve size. Like for example, I'll do this all the time. If so I wrote a compiler recently, and I needed a bunch of different things to allocate. So for example, I had a range that I allocated the AST nodes out of, and I had another range where I allocated string symbols out of, and I had another range where I allocated source info data like line numbers. I had another array where I allocated all the white space because I wanted to have a reversible transform. So I had all these different ranges, and they were reserved based on a multiple of the source input size. So for example, with the white space range, I reserved it to be the size of the input file. Now obviously the file is basically never going to be the full, the white space buffer is never going to be as big as the whole file because you're usually going to have a lot of non-white space in there. But it's really easy to do these reservations for the worst case, but then the commit is only as large as needed. And this way you can have this very nice linear way of doing things, and it's extremely efficient. And you can afford to do those big reserves. I mean, like on 64-bit systems, you can easily do many gigabytes worth of reservations, even if you only ever use a megabyte out of each of them. Windows 8 actually fixed an issue where there was a lot of commit overhead. There's like a 500x or 1 to 500 commit to reserve overhead because it commits storage for page tables to accommodate the worst case. On Windows 8 going forward, that was reduced by like 1000x. So now if you commit, it used to be that if you tried to reserve a 1 terabyte range, it would commit implicitly 500, like 512 megs, which is too much for a lot of use cases to have that much of a commit just for a reserve. But I think on Windows 8 and later, now the same case where you do a reserve of 1 terabyte now only commits a few hundred kilobytes, so it's like 1,000 times less. Or yeah. So anyway, these are nice tricks to remember, especially on 64-bit. Okay. So now we have these allocated. I have my add profile thread, and I now have to go and parse the events, which I don't have, right? I don't have thread GUID. So I have to go and find that. Man, I don't think there's anything I hate more than the MSDN docs for this ETW crap. Threads. If people have questions about some of um, the virtual memory stuff, I can talk about it a little bit more. I think it's not as widely it's not that complicated, but it's not how people are used to working with memory. People are used to having, you request a lot of stuff from the operating system, and then you do the typical kinds of fancy allocation techniques. But these linear techniques work really great on 64-bit if you use large reservations and then small commits that grow incrementally. So it's a different way of doing memory management. And it works for most cases, actually. Well, not most cases. It works for a lot of cases, and it's really easy. The other thing, of course, is that I don't have to do fine-grained deallocations either. So the ownership of all these allocations essentially hangs off of the profile analysis. So when we clean up the profile analysis, we just go and deallocate these ranges. We should probably... I'm not even going to do that now, but you could do like... I'll do it. Fuck it. Free type. I can't remember what free type is. Oh, I guess you have to set what flags on it. Like if you're... No. Oh yeah, decommit or release. So you can't use these together. This is for decommitting, this is for releasing entirely. So these are mutually exclusive. I think I just want mem release because this is the... I'm specifically not interested in growing and shrinking the commit range over time. It's just literally always growing because it assumes the underlying data is always sort of being appended and never removed. But yeah, all right. Alrighty. So right, we have to start mapping out the layout of these things. So there's a process ID, a T-thread ID. What is the T-thread? The thread identifier. As separate from what exactly? Alright, I guess it's just the thread ID period. Stack base, which despite saying A lot of these things that are listed as uint32 are actually pointers, so they're 64-bit on 64-bit platforms. Stack base is certainly among those, so this is stack limit. Okay, so that's also a pointer. User stack base, I assume the same deal. Affinity apparently was a pointer, which is a little surprising to me. Oh, it's a set of processes. Why is this a pointer? Isn't affinity usually a bit mask? Why would this be bigger on 64-bit? Okay, whatever. I'm gonna pretend. Okay, actually, let me make a note. Affinity, and then there's a Win32 start address. The tep base, the thread environment block, subprocess tag, which is actually an actual 32-bit thing. Base priority. And then page priority, and IO priority, and thread flags. Okay. And then we have to go and parse it. Thread GUID. And I think when I was looking before, it said this is version 3. All right. I think step 1 should just be to output some data here about threads. So what were the interesting things? I think like thread ID, which was thread ID, process ID. Honestly, these two things are the only things we care about right now, because this lets us link up a standalone thread ID with the process. So maybe let's just verify these. Maybe we'll return to the rest in the future if we ever need them. So thread ID and process ID. I didn't close my thing here. Okay. I have no idea what this is supposed to mean. Why we have 2 of them. 4 of them, rather. Okay, I think these represent like idle processes. Oh yeah, this is what it is. These represent the idle process. And there's 4 because I have 4 cores. So at any given time. I mean, that is a little bit weird, but anyway, I guess I should keep that in mind. I bet that they have different core affinity. But I would still expect them to have different tags. Anyway, I'll probably have to treat process 0 specially here. Yeah, this all looks fairly reasonable. Okay. So now that we have that, this will actually be much easier, I think, than the other ones. So okay. We have to find the profile process that corresponds to the process ID. I think we have to guard on that. And we will create a profile thread to the profile analysis. And we will start time is the current time. Stop time is 0 because it's not filled in. Thread ID is that. And then the process, and this is, I guess, the really important thing, is this. So let's see if that works first of all without crashing. Okay. Let us now... Okay, we need to do one more thing actually. We need to also create this thing, but for threads. Actually, that's not true because okay, I'm being a little bit stupid because there's both thread create events and anyway, I need to switch on the event type. And so to do that, I need to go back here and see what these are. So event process start. So I need thread start is 1. This is 2. I guess this is 3. This is 4. So this is data collection thread. Okay. Oh, I'm not doing the switch. So event thread start. So the stuff I did here is really meant for this section. And then when a thread is reported as being dead, we have to go and look it up. And if we get it, and sometimes, I guess we always should, but well, maybe we should assert that. At least until we know exactly what kind of weirdness we might be seeing. If it's dead, then definitely we should set the stop time to the current time. And I guess we also need to, so yeah, let's do the same sort of thing we did for the processes, which is if event type is this, then we also actually remove it from the mapping array. So actually I should do that at the top because this is STL insanity where even looking up a fucking entry will create it. If it will create it if it doesn't exist already, which is kind of insane. Okay, and so this is already created, and so we just have to do that, and then I think that's it. Okay. We should go and add something for threads. Sorry, I just had a thought while we were thinking here. So yeah, let's make sure the linkage to the parent actually works. I guess let's put that in too to make sure it was filled in. Actually, let's not even print the process ID. Let's just print the process. So thread ID, start time, stop time, process, file name. Okay. I don't think I should handle the process 0 events the same way as I handle the other events, but I guess we'll just leave it like that for now. Okay, so if I look at CCZ, which is my process, there's 2 threads. I'm pretty sure that's not all the threads. That sounds wrong. I could have sworn there was, let me go back and re-enable call stack printing. I could have sworn there were some other threads here. Let's turn off this. Okay, so this is 1.4. I should have saved the old one. I thought there was like something in the 65Ks for my thread, but maybe that was a previous run and I'm just, I have that number lodged in my brain for a bad reason. Okay, so that actually looks legitimate. Let me just go back to skipping that for now. Okay, so threads, and then CCC, and yeah, so that was this thread, which I believe is the main thread. Okay, so that's good. I think this looks reasonable. And the stop times are filled in some reasonable way. You can see some of them stop prematurely, which means there's things being created and dying. Chrome apparently is very thread happy, as you can see. Alright. Okay, so our original objective here was to try to do this. So now I think we won't have a process, but we will have a thread. Maybe I should put it here. So that should create some compile errors, and I'm going to use that to figure out where to fix it. Right, so not event thread ID, but rather sample profile thread ID. And then process will be thread process file name. Please work. No, that doesn't work. Why does that not work? Why is it not even... Oh, I think I know what it is. I'm still doing that if check on samples. Yeah, which is garbage. I guess if anything... Let's try this. Yeah, so there's still some of these that are null, right? Okay. Hopefully not all of them. Actually, let me set some breakpoints here. Oh, is it out of scope? I can't see it. Are you kidding me? Maybe I'll turn this back on just so I have a place to break point. So this is null. Okay, and now we're getting some things. I think these are probably... Let's see, so when... I want to see what... Well, let's restart. I want to see what things are giving null. 14.7... Wasn't that... 14.768. 14.768. I think that, yeah, so I think this problem is where you're because of some weirdness in E2W, you're getting sample events before you're actually getting, before you've received all of the thread creation events, so you can't really link things up at that point. Now in theory we could defer the link up, but I don't really care about missing a fraction of a second of a sample profile, so I think, well, if we do it like this, it should be okay. And then we want to put this under this, because we don't want to create it otherwise. And okay, now we're getting samples. And they're being linked up. Okay. Looks about right. Okay, so now all the samples can be attributed to threads and through threads to processes, which means that once we symbolize this data, we can actually attribute everything. Like we can split things up. Like we can say, for example, already on the basis of this data, we could actually say that this process is using X% of, you know, however much of a given execution. Okay, let's just kill this. Okay, now it's actually time to do the symbolization I said like 2 hours ago I would do, but I think between the refactoring and the and hooking up threads, we are now actually in a position to do that. Okay, just get a drink. See if I know anyone. I think this math is actually off, isn't it? It should be pointer size minus commit end. Because you want, so if you think of the invariance, when we're in this loop, we know that pointer size is greater than the commit end, and so this will be a non-negative number when you subtract them, and then we do the page line. Okay. So if I had to guess what was happening before, we were doing an over commit basically, or something like that, because they would wrap around to something negative, and then we're gonna try to do a mega commit, and I actually don't know what's gonna happen in that case, if it's just gonna round up, or if it's gonna commit the whole range, but not too much more than that. Actually, one thing we can do very quickly is we can try to start the process and have it allocate all its data structures, and then see what we're seeing here. Let me also show you a tool you can use to investigate virtual memory. I'm sure if you guys are Windows people, you probably know about all the sysinternal tools. But there's one called VMMap, which is really nice when it works, which hopefully it will. Maybe it won't because I'm in a debugger. Okay, so committed, reserved. How much is reserved? Doesn't say that. Well, okay. Just because I quit the process, it got weird data. Alright, maybe we'll look at that later. Okay, so I think what we have to start doing is symbolization. So let's pop the stack several levels and get back to debug help. I think my first step is actually to do all that work separate from anything related to the profile, just to kind of validate my understanding of the basic steps of how to load a module before we start doing anything fancy and trying to match up the data in the profiles. We can just do it manually by looking at the log, finding an instruction pointer. You know, we can kind of do it barehanded until we know everything is working reasonably. So yeah, it doesn't have to be a process handle. We can user search path. Okay. Invade process. Enumerates the loaded modules for the process and effectively calls. Okay. So third parameter is if you want to I'll actually put this into a function. Test debug help. Right, I guess we need some extra juice here. Ignoring, oh yeah, this is classic. Pragma warning, disable. Apparently I can't spell. Okay, that worked. Now we have to, which one is it? Okay, that worked. Alright, so let's see if that works. was successful. Okay, next step. I think load module. What is it called? Something module. Load module 64. Sounds about right. Okay. Right, so sim load module x. Don't want to type that constantly. Null handle, because we don't do that, and then an image name, a shortcut name, creates a name using the base name. Okay, so the image name was actually the image file name, I suppose, right? And then this should be null because we're not going to fill that in ourselves. The base of DLL, and yeah, so we're going to use, okay, I should say something about where we're going, just in case people are confused. I think I mentioned earlier, for those who were on the stream when I kicked it off, that the main point about getting the images from the event stream is that it lets us match up instruction pointers to images, so that for a given instruction pointer, we know what image it comes from. So for example, if you have a bunch of things on the stack, you know, oh, these come from ccc.exe, so it comes from your program, or it comes from, this is like user32DLL, or you know, some other third-party library. So you can kind of classify them very coarsely, but also having classified them, you can then go and actually load the PDBs for those things and get a little more specific, actually symbolize the resolve the instruction pointers to function symbols, basically. Now, the base of DLL basically refers to this load address that it's going to use for that. If you pass in 0, it's going to use what's called the default load address, or the preferred load address. Once we hook this up to the profile data, this thing I'm going to pass in here is what's currently called base in my data structure, but we're just going to pass in 0 for now. And then this would be 0 as well. And the data, this one can be 0. Create a virtual. Right. So I think this is actually what we want. I guess we can. Does it have to be a frickin' UTF-16 string? I guess so. Alright. Does not take 9 arguments. Okay, so process, file, file name, module name, base of DLL, DLL size, data, and flags, so it's 8. Okay. Cannot convert from argument 3. Okay, so it actually seems to be. Alright, awesome. Guess we should figure out how to. It was already defined, so then I wonder why. Alright, never mind. I guess we're just going to leave it like that. And then let's go and find a. Using this API, you can either directly load PDBs, or you can refer to. You can refer to XCs or DLLs, and it will then try to find the PDB from those. And that's what we're going to do for us, because we don't necessarily know what the PDBs are. We just know what the images loaded are, which are like XCs or DLLs or sys files or something like that. So in this case, let's pass ccc debug ccc xc. Make sure that so that's a dword 64 we get back, which I think is the base. maybe the base address. What does it return? Yeah, base address. We should make sure that isn't 0. Okay. So let's step through that. So that worked. And that worked. So we actually got a base address. So we're in business here. Let's try to manually symbolize one of the, well, before we get ahead of ourselves, I'm trying to remember what are these functions called? There's like get something from address. It's been a while since I've actually used this part of the API. It's like from address or something adder. Symbol from adder. Right. So we're going to have some sort of instruction pointer, which we're going to test it first with null to make sure that we get back, not a correct answer. And displacement, which is going to be nothing. And then there's a symbol info. So that's going to be symbol info. And I wonder what that is. This symbol name is variable length. Therefore, this must be large enough to hold the name at the end. Be sure to set. Okay. So max symbol. Max symbol size. We set it like that, and then we actually, I guess we should make this a pointer. And then max name length. I guess the max name length would be max symbols. Just call this symbol rather than symbol info. It would be the total size, but then we have to subtract off the fixed size. What else do I have to fill in, I wonder? Cannot convert, so we have to do a little bit of conversion. So I wonder what I have to fill in. Okay, I think maybe the only thing I have to fill in is actually the name length, so it knows how much it can write. So let's see if I'm right on that. So I got back 0, but that's because I passed it an instruction pointer that's null. And I guess if I do, oh, this is a bunch of leftover junk from yesterday. Okay, invalid parameter, which is invalid parameter is one of those like you did something stupid errors. Like it doesn't actually mean anything most of the time. Thank you, Windows. Okay. Symbol from adder. There's also a question of, is this like a relative virtual address? Is it like RVA? No? I guess because I pass in the base address here for symload. Yeah, so actually let's figure that out. So for CCCXC, we have these two threads, and then we have some images. Okay, so I should, when I do this load time print, I should also base. I should print that as a... Okay, so for CCCXE itself, the base address is this. Maybe I'll call this instruction address. So yeah. And so, wait, okay, that wasn't actually... This is the load address. So let's do that. For now, let's set that the 0 still. And then I guess we have to remember what was the argument that had the base of DLL 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Let's make sure that still succeeds. So that succeeds. That succeeds. Actually, you can pass in any arbitrary load address. I don't think symload really cares. It's just going to use it as an offset anytime you call things that involve instruction pointers. So, okay. But now we have the real base address, which means that if we now go and look at samples, actually, it would be nice to have the stacks back so we can make sure the sample we're taking actually comes from not just from within that process, but from the right image. So let's just turn on that debug again. This old thing. I'm actually going to keep the old stuff at the beginning just so I don't have to rerun it. Right, so if I search for stack colon and then I do a CCCXC. So for example, if I take this pointer here, I should be able to resolve it to, I guess, the main function, because I think that's that call stack here. Just because I'm seeing this stuff here, I'm kind of guessing that it's the message box based on the fact that the profile is running while it's paused in this modal message box. So I would assume that this function pointer here is going to be on the stack, or it's going to be in WinMain. So that seems reasonable. Okay. Let's test that. So remember, before we didn't get a success for the sim for adder for the sim from adder call, and so I'm hoping we will now get something. No, we didn't. So, oh, actually, I think there's a bunch of stuff. I probably do have to fill way more in here than I'm doing. Like size of struct, certainly. It's one of these standard Windows things. I should go and read those docs, actually. Type index. Oh yeah, I have to fill that in, I think. So I have to say I want like sim function. What is it called? Oh no, type index is something else. Actually, I'm going to zero this data just so that the symbol info will be zeroed as well. This must be set plus max main length. Let's carry -1. I see, so max main length actually should be -1 off of this. Reserved unique value. let's see if that fixes it. Okay, that actually worked. Sorry, I forgot that for some reason OBS doesn't actually, like you can't see it right now, but when I'm hovering over symbols, I'm getting the tooltips to preview the values of the thing I'm hovering over. So success right now is saying 1. I guess you can see it. I'll start using the locals window or the watch window more for that. But anyway, so now we're getting success. We should set it back to 0 to make sure that it is because we have a valid pointer and not just because we filled in the struct. Okay, so now we're not getting success, but we were before. So now we should have a symbol. I'm going to actually assert on that so we don't accidentally regress from now on. And is it symtag function? Well, actually, let's we can just look at it in the debugger actually. So let's just go here and then look at what the values are. So type index 2. The tag is 7. If we go to debug help, we should look at the tags like symtag function. 0, 1, 2, 3, 4, 5, 6, 7. No, so that's not good. That means it thinks the thing we're giving it is data, not a function. I don't think that's right. Is it? I guess we can't do that. 0, 1, 2, 3, 4, 5, 6, 7. Let's go and look at the text file again. Let's try a few different ones. Still tag 7. Actually, let me... Yeah, it thinks it's buffer. It thinks this thing we're giving it is the buffer. That is bizarre. The virtual address at the start of the symbol. So what was I getting before? Okay, this is still that thing. I am loading the right. Yeah, it's... Oh no. I know what it is. Oh, okay, that could have been a wild goose chase. I forgot to... This is like a super old exe I'm trying to symbolize against. Holy shit. Ah, okay. Let's cross our fingers and hope that's the last craziness. Nope, it's not. It's the same shit. Okay, well... I misspelled it. Okay. This seems to be at least more reasonable. I mean, like, in the sense that it's actually hitting a function rather than a... rather than something else. Oh, actually, that makes sense. Because, well, let's try again here. Let's see what symbol I was hitting. Yeah, okay. So this makes a certain sort of sense. So one of those call stacks was from, I guess, part of a lookup in the profiler for the hash tables to match things up. And I mean, I was kind of expecting that to be slow because it's, I mean, it's SDL, but also just it's doing a lot of these lookups per, it's doing one per sample. So, okay. Anyways, I think that actually works. We should, I think the ultimate litmus test is to take something at the base, like here, and verifying that, like, I want to see some known anchor that I know for a fact is going to be there, and like that's going to be some sort of main function, either winmain CRT startup or something else like that. No, so this is still the hash. That doesn't seem right to me. Oh, well, no, this is probably not wrong, right? Especially given that these were not. That's, yeah, I think that was what we were seeing there was. It actually doesn't make sense. It's too overeager. If you look at this stack, like there's no way that this would then have other stuff on top of it from NCDLL if it was in the SDL. So I guess I have to go a little bit back to the drawing board. So I'm passing in this load address. Debug help. What if I can RVA? What if I pass in relative virtual? No, what I'm doing is really dangerous. Okay. What I'm doing is extremely dangerous. I should not do it. Because this exe is definitely not the same as it was back when I ran this originally. So I need to have a separate test program I can do this thing with. I guess I can use my B tree actually, since it's not the fastest thing in the world. Well, it's fast, but I have some benchmarks that do a bunch of work. Okay, so maybe that's a good chance to actually benchmark that code. Now we're approaching, I guess, something vaguely practical. So I have to start that. So we're going to run that code. Then I run this. I take a trace. Then stop. And that should now be saved. So if I do this, it should be printed out. Okay, so there's a lot of B-tree stacks here. That should be good. Actually, let me make sure the images are where I expect. So, like, if I look at the B-tree image, these do have PDBs. So in theory, it should work. I think it's just D:, right? Yeah, and even though it's like I said, even though it's whatchamacallit, even though it's released, it should still have PDB, so you can profile a release mode thing. Of course you can. So the B-tree load address is here. And then the instruction address. I'm just going to throw these away because they're definitely not valid. So these are a bunch of things. I guess yeah. Let's just look at this one. See what that is. So this succeeded. Let's see what symbol it is. Yep. So that worked. B-tree interior remove. So I think that actually works, which is pretty damn cool. That means we now just really have to make this work off of the we just have to make this work off of the actual profile analysis data, and we will have symbolized call stacks, for example. All right. Okay. I think right now we're actually not storing the call stack data in the profile, so I should do that too. I think the right way of doing that is to actually use this data dump. So we're going to have a bunch of stacks. And each of the stack is going to have a time, of course. And it's going to... So yeah, I'm going to detach them from the samples because I'm not sure about how matching them up right now. But for now, we're going to do that. Each stack is going to have a bunch of instruction pointers. And instruction pointers length. And we need a range for those stacks, same as everything else. You know what, I'm just going to kind of divide them into these triples so we can kind of see the data that belongs to each of them. Profile stacks. Stacks count, rather. Okay, so now we're back to, well, let's try to how many stacks do we need? We probably need about as many as we have samples, right? So let's just choose that same number. Although that, I mean, that's a lot of data, but again, we're doing the reservation tricks, so we should be good. Profile stack. Okay, and then we're going to make one of these, and it's going to be a little bit different, I think, than the other ones because I want to say instruction pointers length. I want to actually do that as one thing. No, we actually don't need to do that. Okay, and then when we get these, so now we're actually going to start doing something a little more. Do stack blocks not have thread ID? Okay, they have a thread ID. So a stack should also have a thread. Don't need to store process, that's implicit from the thread. Just gonna comment this out for a sec. So this is a thread, not a process. Okay, so we have the instruction pointer count. So if we find this thing, then we can do add profile stack. To the profile analysis. And then we can start filling stuff in. So the thread is this thing. The time is, actually, let me just rename this. So we do this, and then I guess the more interesting one is this one. Let's not call it length, let's call it count. Add profile stack. We should pluralize that. And then we have to actually allocate profile data. And from the profile analysis, and we're going to do this many type size of void star. I think, was that it in terms of what the fields are? So time, thread, instruction. Okay, that looks right to me. Instruction pointers count. Oh, there, okay. Cannot convert from, right. Okay. So now we have to copy the actual data. Stack walk. This, I guess I'll call it instruction pointers size. Okay, so now we should have that all over in our data structures, and we should be able to we should basically be able to replicate the old stacks output now using this method. And this would be, we have like a thread. So at least it's linking up to correct processes. These instruction pointers. By the way, the usually these high process space ones are for like operating system stuff, like .sys files or NTOS kernel.exe and stuff like that. In case you were wondering. All right. So I think at this point, I think I've now confirmed, sort of to my own satisfaction, at least for now, that we have the data we need. So now, rather than just outputting it, I'm going to try to symbolize profile analysis. Actually, maybe I need symbols to be part of the profile analysis as well, because we want the at least in my mind, one of the things you want the profile analysis as a data structure to do is to be self-subsistent in terms of, you want to save it to disk eventually for diffing or consulting it in the future. And so I don't want to rely on all the PDBs and shit being available when you're consulting it again. So ideally, we resolve everything then and there and link things up in a sort of a self-contained way. But for now, actually, for now, let's just output symbolized call stacks. For now, let's just, I guess, do something a little more ad hoc just to confirm and I guess see some pretty output. So step one is we have to well, actually, let's do it for a given process. Because I don't want to load symbols for everything. That's going to be crazy. If you guys have ever tried to open like a trace with WPA, one of the things that makes it really slow by default is that it has to try to get symbols for literally everything in the world that running on the system. So let's not, just for debugging, it's going to be too slow to have to go through that every time. So let's just restrict by process ID. So let's try to find. If profile analysis processes process ID equals process ID, then we want to make sure we found whatever we asked to find. And okay, I guess I'll just call it stacks. Does not take one argument. Oh yeah. So in this case, let's figure out what the B tree name was. Do I actually not print? Okay, that's a little sloppy. So we have to print out the oh, Fabian's here. Probably grimacing over my, my awful code. Alright. So let's see here. So this would be processes and then B tree. Oh, I didn't copy this in. Okay, so B tree, BTXE is this thing here. Okay, so that compiles. Okay, so we found the process, and actually we can just verify that it actually works without, yep, it works without crashing, or asserting rather. So now we have that process, and I keep misspelling this. And so we have the image, and we have the image file name. So let's try to start grabbing in some of this crap. I'm just going to copy and paste it up there and then start getting it in shape. So okay. Okay, so we want to do a well, we want to initialize this at the top. By the way, the reason I don't use current process anymore is if you read the docs, this is actually just a handle to a session, so you can have multiple of these sort of symbolization sessions going. It's nothing to do, it doesn't have to be an actual process handle, although it can't be 0. I believe that's true anyway. We should confirm that by running. And that works. Okay, so I was right. So find the process, and then we have to try to load the various sort of the arguments here. 0 image file name, and then a load address. And the load address is going to be this one, and then this, and base address. Now, I think one thing that can totally happen is that you know, you can fail to symbolize a bunch of stuff. Like, for example, all the built-in sys and DLLs for Windows won't have symbols. And so, well, so they will have symbols, but only if you use the Microsoft symbol server, which, you know, we're not using right now, I think. Although maybe it's set up on my machine in some universal way, like NT symbol path. Let's see. Do I actually use that? Okay, I can't spell. Okay, I'm not using that. I know I have like I have like a symbol cache. So okay, so I and this is populated, but it's not. I don't think it's going to populate it automatically for me. So some of these are going to fail. I'm probably just going to print out the ones that fail for now. And that's fine. It just means some of those addresses in there won't be symbolized. Okay, let's just try that. Okay, so we can't do that. All right, it doesn't like direct pointers. Okay, couldn't load DLLs for much of anything, it looks like. Let me create a separate text file just to keep this data. Actually, I want to see when it's actually succeeding as well. Okay, I think the problem is maybe it doesn't like these crazy UNC paths. God, why am I getting social Microsoft? By the way, while I'm looking through MSDN docs for whatever function I can use for doing that conversion, I think probably, like in general, I think MSDN is extremely good, honestly. Like I know I'm complaining about it for ETW, but that's somewhat of an exception. Most of it is really good. Two things that drive me nuts. The first is that they don't generally cross-link the actual code. So, I mean, maybe this is not the best example because this thing doesn't have embedded structs. But if one of these fields was like another struct that had an MSDN page, I couldn't hyperlink, like there was no hyperlink click for this thing itself. I would have to go and hope it's listed down here, which even if it is inconvenient. The other one, which is bigger one, is this thing down here, the community editions. The fucking community editions are I mean it's so, I mean I don't think. Okay, so maybe this is like, maybe I just found the one case in the universe where things are actually useful in terms of specifying errors in there, but in general, it just seems to be a joke. Like I don't know what they thought. Oh, I see what Fabian is saying. Yeah, you have to do that. Um, yeah, no, I can do that. You're right. You're right about that. No, you're right about that prefix for sure. Um, all right. Let me just make sure this thing comes out right. Um, yeah, let's try that. Let's try it. Actually, let's just call this file name. Oh yeah, I need a double. Right, because it already, I see, because I added, I added an extra thing it didn't need. Yeah. Only works in the Unicode versions, Jesus Christ. Okay, let's try that. Why would it only work in the Unicode version? Is it because they're super long? There's that weird max path restriction, right? That's probably part of the issue. I think max path is generally not long enough to include those like crazy paths, like those like special NTFS volume paths. So maybe that's the issue. Um, oh my fucking god. Okay, so let's just. let's see if I remember. Code page flags, which is 0, and then the multi-byte string and the multi-byte. Okay, so this is the source and the file name length plus 1. And the other one is the Unicode file name. Let's just do this. I'm going to do this in a cleaner way. I just want to 1, 2, 3, 4, 5. 1, 2. Oh, there's a flags argument. Cannot convert from I thought the first argument was multi-byte to wide char. So the first argument is the multi-byte string. The second one is wide char. Why would argument 3, 1, 2, 3 from symload, I see, so I forgot to rename. Okay, let's just make sure this thing actually gets converted right. Alright, it did. Yeah, no, I know the wrappers. What I'm doing now, though, looks reasonable, right? Like, and I'm using the W version. And this is keeping in mind that when I did the manual B-tree load earlier, right, I just specified the d:\\/ address. That worked fine. All right, let's go read the docs. The RTFM always works. Okay, this is the most useless. Oh, here we go. File IO. Disable all string parsing and send the thing straight for assembly. Because it turns off automatic expansion of the fast string. Many but not all file IO. Okay, thank you. That's really helpful. Many but not all. The thing I could do, I mean, if they just had a function for normalizing it, convert. So what is the thing? Convert. It's like NTFS path to. Okay, let's try this. Okay, that function failed. Okay, so maybe we do the conversion like this. let's bring back the multi-byte because I think I need to first do this and then get short path name on the Unicode file name. Short Unicode file name. Didn't succeed. So file name is this thing, and I pass it in. I should check the error, I guess, but the error is like the least. Oh, okay, it actually just says path not found, which I guess is better than error parameter or whatever, wrong parameter. Oh, actually, I guess the first one might actually just not be found. Period. Let's try. Since I expect this one is going to be the normal one, let's try short Unicode file name for this one and see if any of them resolve. No. Or, yeah, none of these resolve. What? Okay, so now it didn't print anything at all. I think because this thing was... Well, I guess it's really fairly dangerous to print this. Since that function didn't succeed necessarily. Alright. Yeah. That's true. The problem is there's actually a bunch of, well, maybe Notepad actually works, but I remember last time I tried this shit with Explorer or Fabian, I couldn't get it to work. This is on an unrelated thing, but like, yeah. Oh, I guess maybe try a directory since it's Explorer. So yeah, that doesn't work. This doesn't work. Okay, short versus long. That's like old DOS shit, so that's definitely not the function I want in any case. Let me just try that real quick. Get full path name. So you take in the old one, the buffer length. So the buffer length goes in the opposite order, and then there's a file part, and this one can be null. Let's see here. Okay, so this one actually succeeded. No, well, I was using those funky paths. Yeah, it doesn't really seem to do anything to them. Probably it just has some. Yeah, so it doesn't remove the UNC prefix. When you reduce to reading, yeah, fuck that. When you reduce to reading Stack Overflow, things have taken a bad turn. But I'm literally just trying to see if there's a function that does what I want. Now, clearly, the function cannot be completely general purpose. Oh, this is so bad. Like people that are trying to do like string manipulation to resolve paths, like no, don't do that, please. Stop writing. Go away from the keyboard. Okay, let me think for a sec. Okay, so here's something I could do. First, let me just try to use create file, and see see when it fails or succeeds. Because if create file doesn't know what, like, you know, instead of using Explorer. Okay, so this gave me back invalid handle. You know what? Let me try doing the equivalent of this. So if Fabian was saying I should use like Explorer or something like that, there's the poor man's Explorer, which is doing this on a at least then I know exactly what's happening here. And I can just run it repeatedly. So that compiles. So now we should be able to do okay. So that failed. And actually, let me just actually let me do the opposite. I want because I expect to fail more than succeed. Let me assert if it happens to not be an invalid file. Why is it taking so long to compile? Okay. WNet. Okay. The DOS path. I wonder if the DOS path thing is actually there's the what is it, undocumented NTFS site or undocumented NT. Yeah, this one. Let's try that function Fabian gave me. It's so undocumented, it's not even on this site. That's fucking great. Okay, let me try this at least. So let's try running this, and I expect it to run without a failure because the path doesn't work. So we're going to get an assert as soon as it actually matches something on disk. So for example, as a, well, let me just pull that into a variable. Okay, yeah. So for example, if I did this, I believe it would assert, because now it's actually, yep, it's actually hitting something now. NT create file should be able to open it. Okay. I'm trying to remember. NT create file. Well, are there even standard headers for that? Oh yeah, there are. I was going to say it's one of those things you just have to know the prototype, but I guess not. What is the header? Things are taking a dark turn when we're using these fucking things. Okay, let's see what this thing wants. Desired access. Okay, so it's basically the same parameters, it looks like. Object attribute. Oh my god, what are these parameters? IO status block. Okay, how many of these are optional? Okay, so this is not the normal generic read stuff. This is like a different thing. So maybe I do this. Oh, okay, no. That is that same set of things. Object attributes, members of this. Object attributes. This could be 0, I believe. Looks like this can all be 0. These are like optional flags. Alright, let's see. I should find a NT-create file example, because I don't know if you need to fill in those object attribute structs and stuff like that. It looks like maybe you need to do. Jesus. File attribute normal, so 1, 2, 3, 4. File attribute normal, share read, file open. just like that. What is this other garbage? Oh, you're fucking killing me, dude. Wait, so this guy here only has a single backslash with the and then he has 2 question marks. Is that something else? All right. Initialize object properties. Man, this is some serious jack shaving just to open a fucking file, I gotta say. A fully qualified object, a relative path name. What the fuck is a Unicode string? Separate, like, why is this not the normal wchar? Oh my god. One or more. Okay, when they say one or more, they actually mean 0 or more, because I don't think most of these look completely like forced to specify. So I'm going to say 0 is a good value for that. If it's a fully wait, so I guess this thing will I'm confused. I should probably read more, but honestly, I want to learn as little as possible about this shit. So initialize object attributes. I mean, when they're talking about objects, I'm assuming they're talking about like NC kernel objects. Right, so actually the file name comes from the object attributes because we don't specify it anywhere else. So let's go back to that the rando code guy. Okay, let's specify a flag to make the gods happy. And so this thing actually has the path. All right. This is length or size. If it's length, we have to divide by vchar. Okay. Object attributes. So I think that's right. And then we have an IO status block, which is God knows what the fucking thing is. IO status block. NT create file. I'm trying to remember. Well, I guess we can just go and look. Is that NTDLL or? Yep. Alright, so Fabian's explaining what these objects mean in this context. I see, so it's just basically whatever namespace mechanism. Okay, gotcha. That makes sense. Although, I mean, this is classic Win32 ceremony for doing the simplest things, but alright. I guess that's why we don't normally do raw NT calls. So I think actually step one is since we know it should work with this file name. Well, that's the question. I guess it won't actually work with this file name, right? Because now we're working in this internal namespace that is different. Well, we can ape this guy. So he says a single backslash question mark backslash should then let you have a normal path. So, or double question mark. Okay, so hopefully this will work. As if. Oh, and I should verify the return values. What does this thing return? Oh, it doesn't return anything. What is this? Let's just validate that this looks kind of reasonable. Yeah. I don't know what the fuck that status means. Oh, sweet. So that actually worked. And we should do the sort of, so that was the positive test. If I rename this to a non-existent file, okay, that's still, so that was not actually meaningful. Hopefully it's not fucking creating it. btree x64 debug. Or release rather. So btree.exe. Well, let's go go check the return values. I should probably not use my normal browser either, since this is on stream. mg create file. What are the return values? Status success. So actually, let me assert when it's not successful, or let me assume that it's going to fail until I figure out how to do something. Okay, there's nothing called status success. What? So this is another, maybe I need like the Windows driver development kit just in order to do this shit. Copy this thing over. Okay. So it's just a long. Object attributes, IO status block, large integer. File attribute normal, file share read, file open, file non-directory file, 0. Oh, and I see. So success for this actually means null. So this doesn't use valid handle value unlike create file, plain create file. It uses this other one. So so null will be the normal case where it fails. Or sorry, null. Well, yeah, null will be the case when it fails. So if we change this to something, well, I guess we can try this, but I don't think that's going to work. But let's just see. Nope. What if we actually try this full thing? It doesn't work either, but I really have no idea if it's because of the path or because or just because I'm not using the right parameters to this function. This is not exactly what I was hoping to spend my time on. Integrate file, example movie or something. I presume this thing just does what I'm already doing, but it's probably not a bad idea to eliminate errors. Except I don't have this shit on my machine, I'm pretty sure. I don't think I have the WDK installed. Maybe I do. No, I don't. Okay. Wait, what? Length is size of object. I definitely didn't initialize that thing. Although, oh, that's the object attributes. Alright, that was the different struct. So this one is root directory, attributes, object name, okay. For the Unicode string, this is whatever. Actually, this is wrong, but I don't think it would ever make it to. No, that's not right. I do have to do that because that's removing the null terminator, dividing by this. I think that's also right. I'm doing this. I'm using this in object case insensitive flag. Object IO status, he's passing a null for this. So maybe I'll do that even though I don't think it's going to make a difference. And he's also using that notation. Oh, so this is single backslash, double question mark, single backslash. Yeah, still doesn't do shit. Okay, what flag square is he using? Okay, so generic, let's try generic read. Object, status, null, file attribute normal. Okay, let's try to do creating something and then just specifying a new thing. And he specifies all of these as null. Let's try that. Nope, still doesn't work. Oh, okay, so I'm just trying to replicate that pretty much exactly. Right object status file attribute normal. Hmm. Okay. This is looking interesting. I gotcha. Okay. Um, it's alright. This thing worked with... Okay, no. So... Okay, so that one actually worked. Well, let's just actually step over it. Yeah, so that worked. And then I want to try with one of these weird UNC paths. Well, actually, I guess... No, I still need to do it with... Let's take a step back. I should still be using create file W. So I guess this would be single backslash double dot, and then this one. And then, what are the arguments? File name, generic read, file share read, 0, open existing, 0, 0. Yeah, invalid handle. Well, okay, let me go actually read this real quick. I have a copy of the Windows internals book at work, but unfortunately I don't have it here. So it looks like the double question mark is basically the way that kind of you address standard, what they call does paths. Wait, this is the full path? Okay. Oh yeah, so here we're down to something else. You can bypass the check on. Right, so I think this notation does seem to be the right one, which is single backslash and double. Oh. Oh no, that was the file. Oh my god, I'm losing it. I was like, that's the function pointer. That's not the thing I'm looking at. Oh man. Is there a to DOS? NT path to DOS path conversion. Oh, here we go. Okay. Oh my god, are you fucking kidding me? That's not what I wanted to see. I'm happy to see the question matched exactly mine, but I'm not happy to hear that apparently I have to do something crazy to resolve it. I mean, I think what I could do is if I can... So first off, I don't have to actually do the path conversion. If I can actually create the file handle, this function here allows you to specify a file handle directly. You don't have to do it by file name. Like this thing here. Although maybe this is not really the true file hand. Well, I don't know if this is the full file or if it's like past the headers in the image or whatever. But in theory, you should be able to open it using the internal APIs and then pass the opened file to this. Yeah, that seems to be the notation. But the paths I'm getting back from ETW are all these like resolved NT paths, right? So, which means I need the double backslash single question mark, no prefix. Okay. Open file from NT path. Open. Create file handle from NT path. Okay, so there's actually a Charles Bloom blog. I guess this must be back when he was trying to make Google Oodle into more of a I/O library. So this thing, yeah, I think that's the one Fabian mentioned. Okay, so this actually doesn't give you the normal human readable or DOS readable name, but the opposite. So that's what we already have. That's not what we want, that's what we have. Honestly, if I could just get the NT create file method to work, I think we would be in good shape. Let me get back to that then, because I think I've convinced myself that that's probably the only way we're going to get this to work. So double backslash, and then this. I'm looking at this because, well, like there's no way I got this wrong, is there? Like I'm always worried when well, let's see what the docs say. I'm always worried when I see words like length because I'm never quite sure whether they mean characters or bytes. Usually I assume they mean characters. But like if they're expecting bytes and I'm giving them characters, it means they're looking at like a truncated string. Okay, it's fucking bytes. Yeah. All right. I'm happy I checked that. Okay, that's still not working. But that was definitely a mistake based on what I'm seeing over here. Not including. When the length is 0 and this is 1. Right, so this doesn't have to be null terminated. I guess we could. I assume that, well, let me see. I assume that getLastError doesn't get populated when one of these fails. Or maybe it does. Yeah, no, it doesn't. It's just a higher level thing. If I could try to find a prototype for this function. Maybe we can use that. Yeah, I don't have that file. I don't need it though. PRTL string buffer. RTL Unicode string buffer. There's an unbelievable amount of ceremony involved in this shit. Okay, so apparently this function doesn't even work on these direct volume drive device things. Okay, so I just need to forget about it and get this other thing working. This is like the biggest black box I've dealt with in a while. So yeah, the question is whether I just need an account to get this or not. Okay, here we go. Oh, hey. No, the size of, I think, I don't know how much stream delay there is, but I already fixed that. If you look at the, I did the division by W chart earlier, but actually, if you look at this, if you look at the MSDN page, it says the length is actually a size in bytes. So I had the bug earlier, but then I changed it to this. Length in bytes. Oh, because it doesn't want the null terminator. Oh, that's definitely true. Okay, that's definitely true. Yeah, latency. Okay, I'm gonna start typing. Hmm. Well, I mean, it was definitely a mistake. I imagine it would have created issues as well. I feel like I'm as close as it, like all these other code samples I can find. I'm close enough that that should work. Like all the other stuff seems the same. Hmm. Yeah. If this thing had an XC, like if this thing came as a, whatchamacallit, if this thing had a binary rather than just code that I don't apparently uses, well, okay, maybe I'll actually clone it. Okay, I'm just going to try to get this building. My theory being, like, I can at least do A/B tests on the paths themselves to make sure that I'm not, like, that it's not completely off in the weeds. And then I should be able to go from there. Yeah, let's try that too. I'm willing to try anything. Yes! You are the best, Fabian. I could kiss you. Ah, that was good. That was really good. All right. Congratulatory Cook Zero. Oh yeah, this is of course it's only the beginning, but at least we've done something. Oh, loading symbols I'm less worried about because now we're in the realm of things I vaguely understand, at least in theory, whereas this is like the black box from Redmond that I have no intention or even desire to ever look into any again. So okay, let's just wrap this into a function, I guess. Create open image file. And so okay, let's live dangerously. Let's bust out the allocation. Um, well, okay, let's what's it? Unicode file name. File name size. What does that return? I think that returns like white chart length, let's call it. Make sure that's not 0. When we do this, Unicode file name size. Well, this was in bytes, and this includes the null terminator. We're actually not going to need a null terminator, so we should just do it like that. Because none of these functions actually care about that. Conversion from, okay, fine doing that. Okay, so let's just check. Okay, I don't actually use it right now. Let's well, I guess this one, let me put it in the other order. Then I'll call image file, open image file. Okay, so this is the file name. Actually, that's not right. We wanted to be able to use one of these raw things. Doesn't have the right null terminator, but that's actually fine because these functions don't need that. Wow, that worked. Okay. Where do we put the code to oh, we actually have it all the way up here. Just going to change this back so it will keep working when we return to it. Alright, I guess we want to go back to this momentarily. And then output symbolize stacks. Oh, I think that was just for reference. So yeah, we initialize debug help. And we actually don't have to open image file. We can just do that directly. If so actually, let me just run this right now, just to see that everything works out. Just so this would just open then close all of these things. Wait, didn't we call this? Output symbolize stacks. Okay, so that was actually fine. That actually worked. Okay. Oh, sorry, I guess this would be continue to make sure it processes all the images for that process. Okay, so that... Okay, so it failed to open some of these. Let's see what... Make sure it actually could open some of them. Okay, so there's just a few things. It's odd that it was unable to open OLE while it was able to open all these other ones. Interestingly, it was all the ones at the end. Okay, that's interesting. I should keep a note of that. Alright, so now we have them open. Fortunately, we can get rid of all this junk. I think we can try to do this. Let's see what happens. I actually have never used this function with direct raw or with file handles directly. I've only ever used it with paths, so this will be interesting for sure. Okay, that worked. I guess I should also call sim cleanup at the end here to be a nice person. So now we should be able to what did I call it? Stacks count. Let's just make sure that prints. Okay. What was that function called? Sim something for sim from adder. Okay, let me just copy this thing here. Return bool. Okay, so if this exceeds, then we print symbolized. Otherwise, we just print some pointers. It's working. Yep. Check this shit out, motherfuckers. Hey Fabian, you said it was only the beginning. As far as I can tell, we're fucking done. I guess I've been programming since I was a teenager. I don't know exactly when I would consider myself a programmer. I don't think I got seriously focused on it until I was 15, but I guess I've been doing it since I was like 8 or 9 in some form or another. Oh, and the other thing I should do is I should do this. Actually, I guess that's not too easy. Well, I can get image from instruction pointer and do profile stack, thread process, instruction pointer, file name. Alright, the reason a lot of these aren't symbolized, by the way, is because the function in theory is only really trying to... So I should actually, if profile stack thread process is not equal to profile process, then I should skip it, since we're only scoping to the process for now. Yeah, so you can see all of this is really well symbolized. There's not a lot of unresolved pointers in this. And you can also see I have some of the NT symbols already. They're just cached locally from the symbols from the Microsoft Symbol Server. So okay, I should remove that thread shit. I don't even know what that is. What do you think? Not too fucking bad, is it? I think one thing I want to do just for cleanliness is profile image. I should have a plain name, and I'll create that just by taking the tail of the file name. So add profile image. When I add the file name, um, and here we'll use the name. Pretty fucking good. Like, honestly, this is all we need to start doing all the sort of accounting math, or all the math for bucketing things and accounting, you know, all the histogram shit. Let's see who's around. Okay, so this is some sort of kernel thing I don't have symbols for. But you can see even some of these other DLLs I do have symbols for. I'm just gonna tweet about this in case someone wants to check it out. Come and check out the boring stream. Could you do anonymous ones? I guess you can. Alright, I guess the next step is to start to actually... You know what, though? I think I mentioned before we started Symbolization that I kind of want... I kind of want the profile analysis data structure to be self-contained. So I think one thing I'm going to do is after you symbolize a profile analysis, it's going to retain the symbol data somehow. So I think maybe the next step, sort of, well, before we move on to actually generating all the all the histogram crap, is actually doing that. Because right now we can only get this data as long as we have the debug help handles open, which is, you know, you might want to save out a profile analysis that's fully symbolized and then open it on another machine where maybe you don't have those original PDBs anymore. Like, for example, if you're like ETW actually supports this. I believe it actually has a way where you can save out in an ETL file. You can actually save out a fully symbolized dump, or maybe not. Actually, maybe that's not true. But one case where that sort of thing is really useful if you're doing professional work is to be able to just, like, for example, have well, I guess there's different cases. Like, so a pretty standard workflow is that you get a crash dump from someone, maybe in QA, and then you have to make sense of it. Usually, though, you can do that on any machine as long as you have shared symbol servers internally where all the builds get their PDBs archived. But anyway, in any case, it's definitely nice to be able to sort of process a profile or an analysis and just have it now be sort of have slurped in all that data, and it's always there. So I think we should do that. Okay, so I think we probably we shouldn't even, like, I'm going to put this there just as a reminder that maybe we want it for debugging, but I think in the final product you don't want it to complain about not being able to load PDBs, because some of that is just a fact of life, I think, for operating system stuff, for third-party things you depend on, so it shouldn't spam you too much. Is there anything else really critical I need to do here? I think this is pretty good. Well, this is good for the output, so I think now I want to turn this into basically like symbolize profile analysis, which will do the same basic process, or the same basic traversal, but it's going to permanently lodge symbols as it finds them. I think it's going to do that process by process, so it's probably, okay, so I think one thing we'll need to do is there will be a new type of thing called a symbol. And a symbol will originate from an image, and it will have a name. So we need symbols. We need one of these guys. Profile symbol. This code is getting really repetitive. Honestly, if this was like C++, I would use a template for all this crap. I guess we are in C++, but I'm trying to keep it. I don't know why maybe I just use templates for this stuff. All right. So we do this, and I think the process is when we're symbolizing. One thing that's interesting is you have to. I guess there's a few different ways you could do it. So we have you can have separate symbolized sessions, one per process. So maybe we can do like symbolizations or like one thing we can certainly do is we do effectively this once per process. And that transitantly creates, yeah, so I think that's what we need to do. I'll use a map for that. So we need a map from profile processes to handles, which we call symbolizers, and so I think step one so step one is just create process symbolizer. Let's see, so yeah, we basically, so the thing we want to do is create process symbolizer, or maybe initialize process symbolization. Okay. And so this basically I mean, let's just do it in line actually. I don't want to, it's not really that much stuff, is it? It's basically this code. So, we first initialize, and that always has to succeed or something is very wrong. Then we have to go over the images. Actually, what is handle? Is it just like a void? Yeah. Since we're just using them as integers. So, oh, this should definitely, I think this should be, should do the cast there and then. Okay, so this will, let's see what this will do. This will go through all the processes and create symbolization sessions. We should have a corresponding, just copy and paste that. We should have a corresponding sim cleanup. So let's just try running that. So you can see this takes a long time, and that's one reason you generally only want to do this for a single process. So probably probably we want to be selective about this. So like you can choose to do it for certain processes. Okay. I think I'll do it like this. Yeah, so let's just do sort of what I actually set up to kind of do initially. Then we can steal some of this stuff. Then we can just use a handle of 1 because we're going to be done with this handle before we are. So yeah, we don't need this. We can bring back all of this, and we don't need to do this in a loop. So this should be I. So let's just make sure this does at least the loading part of the old output code. Right, it did, and that was super fast, which is what I like to see. Okay, so step 1 of symbolizing is to do that. I think step 2, I'm just gonna, because this shouldn't be, this diagnostic stuff is not useful anymore. I think now we actually iterate over, well, again, it's basically what we did here, so let's just use some of that code. So I think the difference is we now want to annotate the existing stack pointers. Yeah, maybe that's the way to do it. So these are like 2 parallel arrays, and they're going to have the same size, but of course some of, let's see, some of these, so it's actually this, some of these entries can be null if they are not symbolized. And right, I think one thing I will need Profile symbol. Okay, the profile symbol did have an image. Actually, I think I want images to have associations with processes reversed, because that way we can go from a stack to an image to a process. Well, sorry, we already have. No, that's actually, I think, correct the way it is. Never mind. All right, so let's see here. We're skipping things that are not in our thing. And what was that invocation we do? We do this. Add profile symbol. I just want to make sure that, or sorry, add profile stack. I want to make sure that when we add a stack, we should also, right, we should okay, so we didn't close this out. Okay. So now when we find a symbol, we can actually look at the stack and say, hey, we want the jth symbol should be equal to something, profile symbol. Profile symbol, profile analysis, and then this thing can come from the instruction pointer, and the name is going to be allocated on demand to be equal to name length. I'm trying to remember if this includes null terminator. It does include null terminator, I think. Actually, let's go check. Let's see what. All right. So we allocate some profile data of that length. We then have to do a mem copy to populate it. All right, we also need to specify the process, right? Profile process. let's run this. Okay, it's because I never actually allocated a range for symbols. Let's allocate a gigabyte because this is just the reservation, but I can imagine there can be quite a lot. Actually, I think the way I'm doing it here is wrong. Sorry. I do too many allocations with this approach. I want to, yeah, this is bad. I don't want to allocate a unique string because I know there's actually like symbol index. There's basically a way, there's like a unique ID for the session. Let's see here. Symbol info. The unique value for the symbol. So what we're going to do is we'll have a hash table that maps from whatever type that is, which is ulong, to a profile symbol pointer. So this will be like this will be symbols, and in this case, there's sort of like let's say well, actually, so we'll do it like this. We'll say we try to grab it like this. We try to grab it from the table by the index. Oops. And if there's not already something there, then we add it and populate it. And then we have to put it back in the hash table so it can be found by subsequent attempts at whatever. And then we fill in the slot. Oh, right, and I was also in the middle of adding my allocations up front. Right. So yeah, we're doing a big thing here. This was not stacks, but symbols. Symbols count as 0. Allocate does not take 3 arguments. Oh, I have to do the multiply myself. Okay. At least that couldn't open for symbolization. Alright, so now after we do this, it should have filled in a bunch of crap, and I think what that means is rather than making this like output symbolized stacks, we should just be able to do a like output stacks period, and so essentially we will just iterate over all stacks. And rather than doing this junk, we will just say if profile stack, well, so let's see here. We have this one, and we have this one. If profile symbol, we do one thing, and we grab this one. It has to be profile symbol now because we're doing the other one. process no longer relevant. Alright. Alright, we haven't run it yet. So now if we add output stacks, does not take one argument. What is, do we still take the process ID? Yeah, that's no longer relevant. Okay. So that seems to work. So this is more data than before because we're not filtering by process in the stacks we output, but we've only symbolized the B-tree process. So you're only seeing symbols for images like DLLs and XEs that are actually part of a B-tree stack. But yeah, but this is pretty cool, I guess. So now we have kind of decoupled we've decoupled our reliance on debug help from our own data. So basically the only step, there's no data related to debug help that now persists inside the profile analysis data structure. All that stuff both lives and dies inside this one function. There's literally no other debug help stuff now. And by the time we're done with this, all these like symbol things are gone, and we clean up. And so that's how we want it. All right. Okay, we have only 800 lines, which is actually pretty good for the amount of stuff we're doing now. Do we still need this? Yes, I believe we do. Okay. Oh, hey. Yeah, no problem. Glad maybe it was entertaining and or educational. Actually, I think the correct interface for this actually is like this. You shouldn't, I feel like, because then you can use it as a helper function for other stuff. No, actually, let's just leave it. Oh, and I undid one too many. What was I going to say? The other thing that would be useful to do actually before is to do a symbolize on process 0, because process 0 has a bunch of images associated that are basically the drivers and other operating system images. And so by doing it this way, we should be able to get some of the internal Windows stuff symbolized better. By the way, we can also try to symbolize another process, like for example, yeah, I don't know why this thing is not getting symbolized. Or yeah, why we're not getting stuff for that. Seems like a regression. Weren't we getting everything symbolized before? Let's try. let's just rename this function output stacks. Oh wait, we were profiling not CCC but B-tree, so that actually makes sense. Yeah, so these are really densely symbolized. The only ones that aren't are the ones right at the beginning. Typically when I've seen this, it's because we're getting some ETW events out of order and we're not actually getting a chance to load things before they've come in. But that's not a big issue because it takes a fraction of a second and then we're all caught up. Okay. Hey. All right. Let's see if someone says something on Twitter. On the Twitters. Benga boys. Random spam is always good. Oh right, yeah. I actually wanted to. The thing I think I said was that it would be nice to. Let's try to find out. Let's try to find out the PID for the Visual Studio process and see if we can actually get some stuff from that. Devenv is PID. There's multiple devenv processes. That's a little odd. Okay, let's try this one. Yeah, we're getting some stuff. Apparently there's a bunch of CLR VM stuff. Like I said, I don't have full... Like this is only, I believe, pulling from the... oh, this is funny. Is assert ATW enabled. This is only pulling from the symbols that are already in my local symbol cache. I'm not actually... It's not pulling from the servers directly when you do this, I believe. Although maybe I should set that up. Yeah, I won't do that right now. That will definitely also be a lot slower. But yeah, so this is working as well. Should be some main function. All right, I should have mentioned, by the way, I didn't realize it as I was doing it. When I was doing this thing where I was uniquifying the symbols through this hash table, one thing I didn't realize at the time, but which is totally true, is that the other thing this does is that it means that the symbol pointer itself, the profile symbol pointer, is now a key we can use for histogramming. So before we were using, if we were just relying on the strings to be the same, that would not be great. We're in fact not relying on the strings, we're relying on the index, which, so even if there's two functions that somehow are the same name, um, which I don't know if that could happen within a single process, because of, linking, needing things to be unique for the names to link up. But yeah, and at least this gives us, like, we can do straight up pointer compares or hash on pointers or something like that in order to figure out when things are bucketing. So I think the next step, after I take a toilet break, is actually to do a histogram of these suckers. So if you just give me 1 minute, I'll go to the bathroom. All right, I'm back. Um, all right, I think now that, so what have we done? We have symbolized everything, which means we can now go and we should now be able to go and build a query. So probably the most basic query is just to give a histogram of everything. So let's do that. Output histogram. I'm going to figure out how to structure this later. For now, I'm just going to output it directly to the console. Probably we will want to output maybe CSV files or something like that, or some other data format. By the way, I don't think I've talked about this. My goal is to not have any real native user interface for this. My goal is to basically generate data that you can look in other forms. So, for example, CSV files for stuff like histograms. I was thinking that even if you want some sort of interactive tree for certain things, I might be able to generate Excel files, or actually HTML files is probably the bigger leverage thing you can do. But I'm hoping I can get away from doing a UI and just generating nice sort of spreadsheets or other forms of data that you can traverse and manipulate in other programs. So that way you can also do data analysis beyond the ones I'm building in. So anyway, let's compute a histogram from profile analysis. And oh, I say the other thing I haven't done yet, and I totally should have, is for a profile sample, I should also have a symbol. Let me just do that before we get into that, because that was an oversight. So we want to also go through the top level samples. Let's do that first. And profile sample. We don't do anything. Yeah, so we have the same thing. We don't try to symbolize it if it's not from the process we're handling. And then I think we have to basically do the same thing here. I should probably factor this out. So what's the right way to factor it out? No, let's just do it. It's not the worst thing in the world to duplicate code for something this small. So this is symbol data, symbol data. If profile no, we still want to do this. So we check the symbol table we've been building up, and right. And I think the difference is that here we say sample symbol profile symbol. So regardless of how we arrive at that symbol, we do that instead of the instruction pointer. Why didn't I have that in my struct? That's another massive oversight. It's because I've been so focused on the stacks. The stacks themselves, though, are pretty much the centerpiece, so it's not too surprising, maybe. All right, symbolize. So yeah, we use the instruction pointer. Okay, this thing is work in progress. Let's just rerun it to make sure that things are still working. They're not. I see, so some of these actually don't have threads because they're really early in the session. You know what, we should probably discard these. See, that's confusing because we already do check that. We only add these if there's a profile thread. Let me try to run again. Oh, I'm casting. That is a typo. I shouldn't do a cast here. That's why, if I hadn't done that cast, it would have told me that I made a mistake. Good old type checker. Alright. So, we should also try to output samples. Yeah, I was doing that here too. I don't know why I got in the habit of doing this cast. That's really error prone. So if this sample does not match, then we skip it. Otherwise, well, I guess we bifurcate on the, so we need the same thing here. I think we're actually just going to oh, we need the instruction pointer too. And you know what? I'm actually going to output it first. The reason it's nice to output it first is that you get alignment between the symbolized and unsymbolized cases. Alright, and then, yeah, instruction pointer. Name, and then the other case, we just have the plain instruction pointer. Thread is not, oh right, it's not the symbol, it's the sample. Okay, let's just make sure these. So yeah, you can see now everything is aligned between the translated and untranslated cases, which looks much nicer. Alright, let's try to do the, an output process samples as well. Actually, let's do this one for now. Okay, that looks very wrong. I think I know what it is. It's because I don't actually fill in the instruction pointer. That would do it for sure. I should also do symbol 0. But definitely instruction pointer equal to sample profile instruction pointer. Okay. So this is the instruction pointer at the time each sample was taken, which is, you know, that's if you want to do, I guess what you call like inclusive time kind of measurements, this is the thing you want to do. In fact, this is the thing I'm going to use for my histogramming, at least initially, and that's why I wanted to make sure these were symbolized as well. Alright, so query time. histogram. Again, let's scope it by process. So once again, we need that. Actually, you know what? It is long overdue that I write this. Guess I don't actually need to do that here. Yeah, this is a useful function. I'll keep it. I think I'm going to start using it more. It's so convenient to profile group. Too many p words. Okay, so it works. Histogram. All right. So the name of the day is we're going to iterate over all the samples. And well, first off, let's skip the ones that are not of our process that we've expressed interest in. So we just skip those. And the thing we have to do is we need a histogram, and it's going to be bucketed on profile symbol counters. And we mentioned, I mentioned before that because I uniquify those on symbolization, I can actually use their sort of numerical value as a unique key for bucketing things. I don't have to do string comparisons on the function names or anything crazy like that. All right, so this is just going to be a mapping to integers, and it will it'll be almost the easiest thing in the world or simplest thing in the world, because we'll just, and I guess this is one case we'll do right now where so let me think, can we actually, I guess the one hitch is that things that are not symbolized all have value 0, and so for those we want to do it on the instruction pointer. And I'm trying to think of if we can easily distinguish those two if we keep them in the same table. The one thing you can do is to, well, let me think. For now, let's just ignore things that don't have instruction pointers. Well, maybe return to that later. Mostly, if we can't symbolize something, we're also not, I mean, we still want to know how much time it took in there, but it's not the most useful thing. Typically, there will be things on the stack that are symbolizable, and so we can get a handle on them through that. So if this is not the case, or the profile samples symbol, or there's no symbol, we skip it. Otherwise, we can use the symbol as a key, and we're actually just going to do this. We don't even have to serial initialize it because the STL will default initialize, which is like one of the very few cases where that weird behavior comes in handy. So let's just try to run that. Okay, it didn't crash. Always a good sign. Now let's I just want to sort it. God. I don't want to use the STL so much, but I just don't want to... I'll potentially rewrite this later, but for now I'm just going to go for what's convenient. So we'll make a pair of... and this will be the... I mean, this is also technically a histogram. This will be the, I guess, histogram vector. And God. I try to not use the STL if I can avoid it, so I don't remember half these functions offhand. Cannot convert from int profile. Okay, so I just need to do this. Okay, that actually works. Now I want to sort it. Okay, the autocomplete is getting fucking on my nerves here, guys. No! Why is it not autocompleting to sort? It's because I have to include it before it knows about it. std sort. There we go. I assume the third thing... Well, maybe they actually have a default lexicographic comparison, which is what I want. If it does that, I'll be happy. Oh my god. That's cool. Okay, that's useful actually. So, okay. So now we are going to... let's assume like 3 digits, typically at most, maybe 4. Well, actually, let's just do this plain. And then we have the symbol name. So in this case, it's literally just deref it and get is it first and second? Let's try that. That is... Oh, I have to go and say this. So the first of this thing is the integer, and it's being sorted in the wrong order. But I guess we can fix that like so. And then for this, we want the name of the symbol. All right, so this is our histogram. So that's useful. Honestly, that by itself is already what a non-call stack profiler would give you. I want to do the alignment. Can I do it like that? Yeah, that's what I wanted. I guess maybe like 5. I guess I'll post that as a little advertising. Okay, what next? It's already a good. Maybe I should take a break soon because I've been coding for. I think I started around 10:30, so that's like a good 5.5 hours, which is a lot to just crank for me at least. So maybe I will take a break. I'll definitely do more tonight, but I don't know if this was. Yeah, I don't know if people get anything out of this, but hopefully the result, which is a profiler that's really high performance and is kind of getting there. Obviously, it doesn't have a user interface right now, but we're already starting to get histograms and stuff. Hopefully, that's kind of cool to see how it comes together from scratch. So anyway, yeah, thanks for coming by and hanging out. I guess before I disconnect, does anyone have any questions now that I'm done coding? I'm happy to answer anything. Sorry about that. Looks like there's no questions. So I think I'm just gonna take a break now, but I'll be back tonight. This will also let me think about what probably like the next most interesting step is. I think that step will probably be, if all you have are flat samples, then you can't really do anything except this. So if all you have are samples, essentially what I did here is already all you want, all you need. But if you have call stacks, then you want to be able to get a little more specific. So for example, if you have a leafy function that accounts for 90% of the CPU time, you want to know what are the call stacks that led to that leaf function. And we have all that data. We just have to sort of organize it so we can enable those queries. But anyways, I think I'm gonna start tackling that tonight, maybe in another 4 hours or so. So thanks for coming by. See you later.